So quick review, and I'm going to actually white out the top here. Quick review from your last couple days. And we're going to pull from things we already know, like always. Today's going to be new, but it's not actually going to be new. And at the top of your notes, it actually gives you steps to do this. I hate steps. But quick review, things we know. We started with slope being the change in y over the change in x, right? And then we took what we know about proportional relationships and we shifted the y-intercept to make things look like this instead of this, right? So we moved from that to that. We go with that? I hope. Give me some head nods. Okay? And then we learned a new form. We haven't messed with the new form yet, but we learned that. So this one was called slope-intercept because it's made with a slope and an y-intercept, right? Then we see a new form now that looks like this. And this one's called standard. And actually, tomorrow we're going to find out really what's awesome with standard form. But so far we know. And guys, here's how you know they're both lines. Check out the variables in this equation. The variables are x and y, which make an ordered pair. Check out the variables in this equation. The variables are x, y that make an ordered pair. They're the same equation. One has x and y on the same side. One has y by itself. That's the only difference, okay? One has x and y on the same side. One has y by itself. And as we get further in the unit, you're going to see like the pros and cons to each one. Remember, I think you've heard me call things like this tools in the tool belt. There's sometimes I like to rock standard form, and there's sometimes I like to rock slope-intercept. And sometimes one's definitely easier than the other, okay? So you got to build the skills and have the knowledge, though, to know when to pick and choose what's better. All right, so here's my favorite way to start this off, and I'm going to be looking for some visual feedback. We already graphed lines. Is anybody brave enough to unmute and remind me how we graphed lines in Unit 6, the functions unit? How did we graph these things? We had a whole day of homework on graphing lines. Anybody remember? I'm hoping you remember. Crickets, baby. All right, maybe this will jog your memory. I'm hoping. Let me know if this jogs your memory. Does that jog some memories?
Didn't we have like an equation to find y if we had x?
Yeah.
And we'd like draw it out like that, and then
we'd
have all the x values.
We'd pick a domain, right? So I'm going to make a point on number 3. Number 3 of that fraction, remember? And if we pick the domain for number 3, I was encouraging something like a -5, 0, 5 for domain, so that fraction would kind of go away. Do you remember doing this? And so then we would take these x values in, and you would substitute in. And you'd do this every time. You'd write y equals 2/5 times -5 over 1 plus 2. Because when x is -5, you could use your equation then in that function to pump out -2 to 0. And then you had point -5, 0, right? Do you guys remember doing that? And then you slap a 0 in here. Well, if you slap 0 in there, 2/5 times 0 is 0. Y is 2, so when x is 0, y is 2. And then you would slap a 5 in there. And when x is 5, y would be 4. And then you'd graph your points and you'd have a line. Remember doing that? It was like some work. Even me being pretty good at explaining to you was some work, right? Do you guys remember that? I'm looking for head nods. You pick a domain, you get a range, you have points, you can graph it. Now, there's going to be an easier way. You guys, would you guys like an easier way? I think you would. Here's the easier way, all right? Easier way is this. There's 2 pieces of information this equation already gives me. And here they are, Jack B. You ready for this? I know that the slope of this equation is 2/5, and I know that the y-intercept of this equation is 2. Now here's what I want to know. Only one of those is an actual spot on the graph, Nate. Which one's an actual spot on the graph?
The y-intercept?
The y-intercept, right? A lot of people want to mess with that slope as like an ordered pair or something. Slope is a relationship, all right? It explains how 2 points are related. It doesn't say it's a spot, right? Infinite things have a slope of 2/5. So here's what I know. I know I have a y-intercept of 2, right? Because b is 2. Also, when x is 0, y is 2. That's why it's the y-intercept, right? I know my y-intercept is 2. Everybody good with y-intercept being 2? Okay? Remember, I'm looking for visual feedback. Give me a head nod no if it's a no, right? So when x is 0, y is 2. There's a spot. Now, that's the only spot the graph gives me. But I know that the slope tells me that the relationship between this spot and the next spot is a rise of 2 and a run of 5. Because slope is rise over run. So that means if I rise 2 and I run 5, 1, 2, 3, 4, 5, I know there has to be another point on my graph there. Because that's my slope of 2/5. Well, guess what, friends? We have 2 points. And those 2 points, when I connect them, give me a line. And that line has a slope of 2/5 and has a y-intercept of 2. So Oliver, this is going to work for like every line. So help me out on number 1. The first question I have for number 1 is big idea. What pieces of information do I have just looking at the graph?
Well, you know that the slope is -1.
Correct. And what else do I know?
And that the y-intercept is 5.
Yes, and which one of those is an actual spot on the graph?
The y-intercept 5.
Because when x is 0, y is 5. Perfect. I know that spot. Now, Oliver, what do I know about the relationship between this point and the next point?
It's slope.
Yeah.
The slope.
The slope's -1. So here's the most common place people put a dot with the slope of -1. The wrong place. It's not that. That's not a slope of -1, right? -1 is -1 over 1, correct?
Yeah. So it would be at 0
Yeah.
negative, or, yeah.
1, 2, 0, 4.
Oh, yeah, okay, yeah, 0, 4.
There is my line. That line goes through 0.5 with a slope of -1. So always check it when you're done. Okay? I'm going to have Tyler. Help me with number 2, please. What information do I know about number 2, Tyler? Oh, man. Tyler, you gotta mute, I think. Something's not right. You sound like Dead Mouse or something, man. We were just listening to Skrillex. Okay. Jack, I'm going to have Jack R help me. I think your microphone's not working, man. That sounded cool, though. Like we were about to have a little dance club party going on there for a second. I was waiting for the drop. All right, Jack R.
Okay, so we know that -1 is the y-intercept.
Okay. So I know my line has to cross right there, right?
Right.
Cool. And what else do I know?
We know that the slope is -3 over 1.
Yeah, cool. So from that point, down 3, right 1 has to be another point. Now, I want you to notice, if I put a point there as well, I could. Check it out. Down 3, right 1. Between any 2 points, it has to be down 3, right 1, right? There's my line. So just double check. If I had a little slope dude here, is he going nice negative there? Check. It's a negative slope, right? Does it cross at -1? Yeah. And the reason, again, that this is the y-intercept is when x is 0, anywhere on this y-axis, y would have to be -1. Cool. Now, I'm going to do number 5 for you because number 5 kind of runs into something kind of fun. I think it's fun, at least. So you don't have to do this step. I like to pull off the important information. So number 5, I know my slope is 2 and my y-intercept is 6. Okay? And that, again, remember, that comes from slope-intercept form, some practice we did from the constant of variation and proportional relationships. But I know it has to cross right here at 6. What do you guys notice if I try to go up 2 and over 1? Who can raise their hand and tell me what they notice? If I were to try to go up 2 over 1. Looking for some hands up in here. Yeah, Ezra.
It goes off the graph?
Yeah, but here's the deal, Ezra. This line is infinite, right? And any 2 points can work to go up 2 over 1. So I'm eyeing this point right here. Because from this point to that point I already had, check it out, guys. Up 2, right 1. Don't get task-oriented, right? The ratio between any 2 points left to right can be up 2, right 1. So that point still works, all right? I want y'all, on your own, to try out 4 and 6, okay? So, Leah, you get to tell me what to do. So what am I going to do and why for number 4?
So we know our y-intercept y-intercept is 3.
Okay, so what do I do with that?
You put that point put the point on 3, 0.
Oh, you meant 0, 3. But next is 0, y is 3. Okay, yep. Okay, then what?
And we know the slope is negative 1/4, so you go down 1 and left 4,
Okay.
and then that's your second point.
Let's check this out, Leah. Is that line positive or negative?
Positive,
Is our slope positive or negative?
negative.
Okay, so let's do something different. So you went down and left, which is negative, negative, which would result in a positive, right? So let's try something different. We went down 1. Which direction do you think we should go from here?
Right.
Yeah, let's try that. So negative, positive, 1, 2, 3, 4. So let's check that out. Do we have a negative line now?
Yeah.
Stellar mistake. Thank you for putting that out there. All right, Ace, number 6. Is it giving you the option to annotate?
No.
Stinking Zoom. I wonder if it's like, do you have a Chromebook? I wonder if it doesn't like Chromebooks or something. I don't know. Maybe it's cool for you though, Ace, because you get to tell me what to do. What am I doing first?
So you know the y-intercept is -5, so you put a point at 0, -5.
There it is. Okay, now what?
And you have a slope of -3/2.
Okay.
But since you can't put a point off the graph,
Yeah.
you can go up 3 and then left 2.
Yeah, let's check that out. So you're saying right there, and from point to point, is it down 3, right 2? Yeah.
Yeah.
That works. So there's my line. Cool. All right, guys, we slayed. So big ideas. When we have slope-intercept form, we know a point. It's the y-intercept. If we know that point, we can then apply the slope to that point to get a second point, and you would only need 2 points to make a line. So which way is going to be easier? XY table with multiple inputs and outputs, or putting a y-intercept and counting a slope? Y-intercept and slope, right? You seeing that that's going to be easier? I hope. So we have one more skill to practice here. Let me get us to a fresh PDF. Who can tell me what they notice about these ones? What's it? Raise your hand and then I'll call on somebody. What's a little different about these ones? Braden?
They're not in slope intercept.
They're not in slope intercept form, they're in standard form, right? They look like this. I need them to look like this. Ain't no thing. Because to get it to look like this, I just need to get y alone, and I know algebra. All right? I know algebra, bruh. So let's do it. So in something like number 12, goal is y equals to be slope-intercept form. I'm going to first subtract 5x from both sides. That would leave me with negative y equals negative 5x minus 3. And then I'm going to divide both sides by negative 1 to get y alone. So y would be 5x plus 3, which you had to do on last night's homework, right? So now that I've done that, I see I have a y-intercept of 3, 1, 2, 3, 4, 5, and a slope of 5, which puts me right there. Oh, man, I got to do better than that, friends. I've got an idea. There we go. That looks nicer-ish. Cool. So I'm going to have Sam tell me what to do for number 13, all right? Sam, what do I do for 13?
Can I use the annotate?
Oh, yeah, go for it, man. Annotate up. But I might, like, write over what you write so it shows up on the video, okay?
So you do minus, oh gosh. Yeah, no, that's hard. You do minus 4x,
Okay?
and then you divide both sides by 3 to get y alone.
Yeah, so one thing I want to show you, when I do minus 4x to this side, I put that term first because the mx plus b action, okay? Yeah, but then like you say, divide both sides by 3. So I get negative 4/3 x plus 7. And I think you guys recall me saying I prefer the improper fraction. That's because this is going to be easier to use the slope, right? 4 down, right 3. So 1, 2, 3, 4, 5, 6, 7. Once I got this, I know I have a y-intercept of 7 and a slope of negative 4/3. And friends, that's all you need to graph a line is 2 points. All right? So once you get it in slope-intercept form, it's kind of like nothing new. Raise your hand if you want to see one more like that before I set you free on the homework. Raise your hand if you need to see another one, because I'm all down for showing another one. All right, I'm going to release the homework on Go Formative. One thing you have to keep in mind is Go Formative is not going to be able to check these. There's a key on the document for you to check, okay? Now, I would do the whole thing or do a couple and check. Don't just copy my work because you won't know what you're doing and then you're going to fail the quiz. So don't do that. All right? Cool.